Welcome to my channel. I am Dr. KP Naidu. In this lecture, I am going to discuss about how to construct a decision tree, okay, using ID3 algorithm. So before understanding to how to construct a decision tree, first you have to know how to calculate the entropy value and the information gain, okay, to the particular features of the data set. So if you don't know how to calculate entropy or an information gain to the particular feature, okay, in the below description I was providing the links. Please go through that link, okay, then you can easily understanding how to construct a decision tree using ID3 algorithm. Why? Because to construct a decision tree using ID3 algorithm, in this ID3 algorithm, we are mainly used entropy and information gain to construct a decision tree. And in this video, in this scenario, I am taking the weather data set. Let us first try to understanding this weather data set. This weather data set contains 14 records, okay, from day 1 to day 14, and this contains four features: outlook, temperature, humidity, and wind. Clear? And the class label is playball, and the values of classes are S class and no class. So here our main goal is to construct a decision tree. By using that decision tree, we have to predict whether what is the chance to play a game or not. Clear? So the next one is to construct a decision tree using ID3 algorithm. First we have to find out the entropy for the target variable. Clear? Here what is the target variable? Play ball is the target variable. So here we are containing total 14 records from D1 to D14. Okay, so in these 14 records we are having the 9 S records: 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why entropy of target variable equal to, so the probability of S into log probability of S minus probability of no into log probability of no. This is the formula of which one? Entropy. That's the probability for S is 9 by 14 into log 9 by 14 minus 5 by 14 is 5. We're having 9 S records. Remaining 5 records are no records. That's why 5 by 14 into log 5 by 14. Here you have to remember the base value of log is 2. Okay. So if you are simplifying this equation, then we are getting the values 0.9395. That is nearer to 0.94. That means the entropy value of target variable is 0.94. Okay, that's the first point. First we have to calculate the entropy for the target variable. So now we have to calculating the gain for the remaining features, that is outlook, temperature, humidity, and wind. Okay, so next we have to next, if you want to calculating the gain for these four features, okay, first we have to know the entropy of the entire data set that was subtracted with the so remaining part of this one, that is entropy of before minus sigma I equal to 1 modulus of Si by S entropy of Si. So Si is a subset of S. Okay, I is the what are the values we are having for the particular Si. Okay, so clearly you are understanding in the next slide. Clear? But here remember, first we have to find out the entropy for which one? Target variable. Clear? So next one is we have to calculate the entropy for outlook equal to sunny. Clear? And then we have to calculating entropy for outlook equal to overcast. Here next we are calculating entropy for outlook equal to rainy. Let's see outlook equal to rainy. We are having how many records? 1, 2, 3, 4, 5 records. In those 5 records, in those 5 records, let's see. we are having Sunny no, Sunny no. Okay, Sunny no, Sunny yes, Sunny yes. Again, we are having Sunny no, Sunny yes, Sunny yes. That means we're having the three no records and two yes records. That's why total 5 records. The entropy is minus 2 by 5 into log 2 by 5 minus 3 by 5 into log 3 by 5. If you are simplifying this equation, you're getting a 0.971. Like this overcast. We're having the total 4 records for overcast. 1, 2, 3, 4. 4 overcast records. So overcast yes, overcast yes, overcast yes, overcast yes. Okay, that means all the outlook equal to overcast records belongs to S class. That's why minus 4 by 4 log 4 by 4 to the base 2. We are not having any no class. That's why 0. So 4 by 4 is 1. Log 4 by 4 is base 2 is, it is also 1. 4 by 4 is 1. Log 1 to the base 2 is 0. 0 minus 0, we're getting the value 0. That means I already told in the entropy in session, if all the records are belongs to the same class in a, for a particular feature values, if all the records belongs to a same class, the entropy value is 0. Directly we have to take the value is 0. Next, coming back to the outlook equal trainee. So trainee class 1, 2, 3, 4, 5. Total having the 5 records. Out of 5 records, okay, rainy S2, and again rainy S3. Clear? So we have 3 records and 2 no records. That's why minus 3 by 5 log 3 by 5 minus 2 by 5 log 2 by 5. Its value is 0.971. Now by using these entropy value, now we have to find out the information gain of outlook. So now if you want to calculate the information gain of outlook, so from the information gain formula, first we have to take the entropy of entire data set. What is entropy of entire data set? The entropy of entire data set is 0.94. That is 0.94. Then we have to take the entropy of each feature value that must be subtracted with, okay, how many records we are having to a particular feature value by total number of records in that particular data set. Okay, that likewise you have to calculate in the gain. So here is information gain of outlook cake. The entropy of the data set is 0.94 minus, okay, so we're having the outlook equals n is 5 records. 5 by 14 into its entropy is 0.971. Clear? And outlook equal to overcast 4 records out of 14. Its entropy is 0 plus outlook equal to rainy 5 records out of 40. Its entropy is 0.971. If you are simplifying this one, we are getting the value 0.246. It is equal to 0.25. Let us remember the information gain of outlook, outlook is 0.25. Similar way, we have to calculating the information gain of temperature, the information gain of humidity, the information gain of wind. Let us see the next one is information gain for temperature. Clear? Here I am directly use the formula. Information gain of temperature equal to the entropy of the entire data set, that is 0.94. Now what are the values of temperature? Hot, mild and cool. Hot records are 1, 2, 3, okay, 4 hot records. Clear? Mild records are 1, 2, 3, 4, 5. We are having hot equal to 4 records. Fine. And mild equal to how many records? 5 records. And next one is cool. So total 14. 4 plus 4, 5, 9. Remaining are which one? The 5 records are cool records. Now we have to calculate the entropy for temperature equal to hot, the entropy for temperature equal to mild, the entropy for temperature equal to cool. We're having the hot records are how many? 4. Okay, so this is hot no, this is hot no, this is hot S, this is hot S. So out of 4 records, 2 records belongs to no, 2 records belongs to S. This is also, this point also I was discussed in entropy value. If the particular feature values are equally distributed to the class. So out of 4, 2 records belongs to the no class, 2 records belongs to S class. That's why its entropy is 1. Clear? Let's hear this one. Okay. So here this is temperature 4, 4, 6. Okay. I think that means the total mild records are how many? 1, 2, 3, 4, 5, 6. 6 are mild records. Okay. Sorry. Clear? So 4 are cool records. Clear? So 4, 6, 4. Clear? So these hot are here 4 by 14 into 1. Why I am given 1 here? Out of hot equal to 4, 2 records belongs to no class, 2 records belongs to S class. That's why its entropy is 1 equal distributed. Fine, it's fine. Next, coming back to the temperature equal to cool. Temperature equal to cool S, temperature equal to cool no, temperature equal to cool S, temperature equal to cool S. That means we are having the 3 S records, 1 no records out of 4. That's by 4 by 14 into S records are 3 by 14 into log 3 by 14 minus 1 by 4 into log 1 by 14. This is the entropy of which one? Temperature equal to cool. Now temperature equal to mild. Okay, temperature equal to mild, how many records? 6 records. So mild yes, clear, mild no, mild S, mild S, mild S, mild no. That means we are having the 2 records are no, 4 records are S. This is the entropy for hot, temperature equal to mild. So 6 by 14 into this temperature equal to mild. If you are simplifying this one, we are getting the value 0.0289. That is similar to 0.029. So this is the gain of temperature. Hope you understood. Okay. Likewise, we are finding the information gain for humidity. The information gain which one? Humidity. The values of humidity are high and normal. So out of 14 records, we are having only two values for humidity, high and normal. Okay. So high records are 1, 2, 3, 4, 5, 6, 7. Okay. 7 by 14 into. Okay. We are having the high S records are high S, uh, high S, high no. Okay, that means we're having the three S records for high. So high S is 1, high S is 2, this is high S is 3. Okay, total 3 records. 3 by 7 log 3 by 7, remaining 4 records are no records. 4 by 7 log 4 by 7. Okay, and they are from the, that is high records. Clear? Again, 7 by 14 into, clear. So remaining is normal class. So normal S2, normal S3, normal S4, normal S5. Clear. Again we're having like this, we're having maybe 6 records belongs to S, 1 record belongs to which one? No. That means 7 by 14 into, clear. So the entropy for what is called as humidity equal to normal. This is entropy for humidity equal to high. So if you're simplifying this one, we are getting the values 0.1516. Okay. So next we have to calculating the information gain of wind. Okay, the information gain of wind equal to the entropy of the entire data set minus. So wind we are having two values, weak and strong. Weak records are 1, 2, 3, 4, 5, 6, 7, 8. Okay, that means 8 by 14 into entropy of wind equal to weak. We are calculating from this formula. Again, remaining 6 records are wind equal to strong. 6 by 14 into maybe out of 6 records, 3 records belongs to S, 3 records belongs to no. That's why 6 by 14 into this is entropy of wind equal to which one? Strong. This is entropy of wind equal to weak. If we're simplifying this one, we're getting the value 0.048. Let's remember the outlook. Sorry, we are finding the gain for outlook, temperature, humidity, and wind. Okay, so now the wind is gain of wind is how much? 0.048. Clear? Then gain of humidity equal 0.16. Humidity equal to how much? Humidity is 0.0.15 something. Clear? Next, gain of temperature 0.02. Okay, gain of outlet heat. So gain of temperature equal to 0.02 and gain of outlook equal to 0.25. Okay, hope you understood till now. So from these features gain values, which feature having the highest gain? Outlook is the highest gain, that is 0.25. That's why from these four features, outlook is the best feature. Outlook is the best feature. Why? Because that feature having the highest information gain. That's why the best attribute is outlook. Now we have to construct the partial decision tree. Is outlook is the root node. Its values are sunny, okay, overcast, rainy. Clear? So now outlook equals sunny. We are having the 5 records from the data set. Those are D1, D2, D8, D9 and D11. Outlook equal overcast. We are having the 4 records. Those are D3, D7, D12, D13. Outlook equal rainy. We are having the remaining 5 records. Clear? So here why I am defining the class is S means, let's see, outlook equal to overcast. Outlook equal to overcast S, overcast S, overcast S, overcast S. That means if outlook equal to overcast, those records belongs to S class. That's why directly I was make the class name is S class. Okay. Now for outlook equals sunny, we are having the 5 records D1, D2, D8, D9, D11. Okay. So from these 5 records, some records are no class, some records are S class. That's why again we have to calculate, again we have to calculate the gain of the remaining features. What are the remaining features? Temperature, humidity and wind by considering these 5 records only. By considering these 5 records only. By considering outlook equal rainy records, again we have to calculate in the gain for temperature, humidity and wind. Okay, similar way by considering these 5 records, outlook equal rainy, again we have to calculate in the gain for temperature, humidity and wind. Okay, let's see, you can easily understanding. Okay, first we have to see what is the gain of remaining features if the outlook equal to sunny. So outlook equal to sunny, we have how many records? 5 records. What are those? D1, D2, here I am right now, I was written D8, D9, D11. First, we have to find the entropy of outlook equal to sunny. The entropy of outlook equal to sunny by considering these 5 records. From these 5 records, S records are how many? S records are yes, yes, 2 are S records out of 5, 3 are no records. That's why its entropy is 0.971. So now Similar way, okay, information gain when outlook equals NE, we have to calculating the temperature with respect to temperature feature. What is the information gain of humidity if outlook equals NE? Again, what is information gain for wind if outlook equals NE? Like that we have to calculate. So the entropy for outlook equals NE 0.971 minus, clear. So from considering these five records, okay, what are the values of temperature? Hot, hot, mild, okay, cool, mild. Hot are no, two records. These are no only. So hot, mild, cool, mild. Hot no, equally distributed. That's why for hot, entropy is how much? Sorry, all are belongs to same class. It is 0. That means 2 by 5 into 0. Let's see here, 2 by 5 into 0 plus we're having the mild records are how many? 1, 2. These no and yes. Out of 2, one record belongs to no, one record belongs to yes. Equal distributed. That's why 1 by 2, 1 by 2, 2 by 5 into 1 by 2, 1 by 2. Its values we're getting is 1. Okay. Plus, okay, next record is hot, mild is over, cool. Cool is yes. Only one record. That's why 1 by 5 into log 1. Okay. So its value is 0. Its value is 1. Okay. Now likewise we have to calculating, okay, 0.971 minus 0.4. Clear? So this value is 0 we are getting. This value is 0. 2 by 5 into its value is 1. That's why 2 by 5 into means 0.4. Now we are getting the gain of outlook equals NE to the temperature is how much? 0.571. Similar way we have to calculate outlook equals NE for the humidity by considering only these five records, D1, D2, D8, D9, D11. We're getting the value 0.971. Hope you understood. Again, outlook equals NE. We have to calculating the gain for wind by considering which records? D1, D2, D8, D9, D11. Clear? We're getting the values 0.02. So wind is how much? If outlook equals NE, if outlook equals NE, the wind future gain is 0.02. Okay, now the temperature gain value and humidity gain value. Let's see. Okay, so humidity is 0.971, temperature is 0.5. So temperature is 0.5 something, humidity is 0.9. So which one having most gain value, more gain value? Humidity. That's why after outlook equals NE, the next best feature is humidity. The best next feature is which one? Humidity. Now what are the values of humidity? High and no. From these five records, if humidity equal to high, okay, D1, D2, D8 are no class, D9, D11 are which class? S class. Okay, so D9 and D9 and D11 are which one? S class, and humidity is which one? Normal. Understood? Clear? So humidity equal to normal, we are having out of 5 to the humidity equal to normal, we are having only 2 records. Those 2 records belongs to S class. That's why I can make it as a yes. If humidity equal to high, if humidity equal to high, no, no, okay. Humidity equal to high, no. So if humidity equal to I from 5 records, from these 5 records, if humidity equal to I, those records belongs to no class. That's why no. Now this one is completed. So outlook equal to overcast is S class. So again from these 5 records, D4, D5, D6, D10, D14. From D4, D5, D6, D10, D14. D4, D5, D6, D10, D14. So in this, yes, yes, no, yes, no. That means we're having two records are S, two records are no, and four records are S. That's why again we have to calculating. Here what you are considering? Outlook equal rainy. If outlook equal to rainy, first we have to find out what is the entropy for outlook equal rainy. So from these five records, we are having two are no class, three are S class. That's why 3 by 5 into log 3 by 5 minus 2 by 5 into log 2 by 5, we're getting value equal 0.971 if outlook equal to rainy. And again, we have similar way. You have to calculating gain for temperature if outlook equal to rainy, gain for humidity if outlook equal to rainy, gain for temperature for outlook equal to rainy. From this, temperature 0.02, humidity 0.02, for wind we're getting 0.971. Which one is more? 0.971 is the more. That's why outlook equal rainy. So wind is the next best feature. Wind is the next best feature. Now what are the values for wind? Okay. So what are the values for wind? Weak and stronger two values. So weak and stronger values. Okay. So from these four, D4, D5, D4, sorry, D4, D5, D6, next D10, D14. Okay. So weak, this is D4, weak S, weak S, weak S, clear, strong no, strong no. So if wind equal to weak, it belongs to S class. If wind equal to strong, it belongs to no class. Okay. So from here, okay, it covers all the 14 records or comes into which one? Decision tree. Now we have to stop the algorithm. So if outlook equals sunny, humidity equal to high, that record belongs to which class? No class. For example, if outlook equal to sunny, humidity equal to normal, that record belongs to which class? S class. So this is the final decision tree. If all the records are comes into the decision tree, that's why now the algorithm is stopped. Okay. Likewise, you have to calculate in the decision tree using ID3 algorithm. To calculate in the decision, to construct the decision using ID3 algorithm, we are using the entropy and information gain values. Now, how to predict the class for given instances from the decision tree. Let's take outlook equal to sunny, temperature equal to hot, humidity equal to normal, and wind equal to high. Let's find out, predict what is the class of this test instance. What is the first one? Outlook equal to sunny. That's why we have to move to this direction. Outlook equal to sunny. Next, what is humidity? Humidity equal to normal. Humidity equal to normal. That's why it comes to which class? Yes, class. Okay. So if outlook equal to sunny, humidity equal to normal, okay, the given test instance belongs to which class? S class. Likewise, from the decision tree to the given test instance, we have to predict the class. That is in depth about, okay, construction of decision tree and predict the class of the given test instance, okay, from the decision tree. Hope everyone understood this problem. Okay. So this is another one. Okay. Now once if you know the problem, now we can easily understand in the algorithm. Clear? First what you have to do, we have to calculate entropy for the entire data set by using this formula. Hope you know how to calculate entropy. Then we have to calculate information gain for each feature by using this formula. So after calculating the gain for each feature, okay, so which feature having the highest information gain, that will becomes a root or decision node. Okay, by using that decision node, again we can split the data set. Let's you can see the data set is split into like this. As a note, after taking the outlook equal to root node, outlook equal to root node, now the data set split into three parts. As a note, now this part to this part again we have to calculating the best feature. Maybe here four records, all records belong to S class. No need to split this here again. But here six records, in this some are having S, some are no. That's why these 6 records again we have to calculate in the best feature. That is the this step. Clear? So after finding the after choosing the highest gain node, then the data set is split. Okay, divide the data set based on the values of the chosen feature. Now, again to each and every subset, again we have to find out the which one best feature. So we have to repeat that entire process until stop when all samples in the subset have the same label, that is pure subset, or where no remaining features. If there are no remaining features, or all the records of the data set are comes into which one decision tree. Now we have to stop the which one algorithm. Then we have to create the leaf nodes. If a subset is a pure or you have no more features, assign a leaf node with majority class label of that set. Okay, so if you're understanding the problem, then you can easily understanding this algorithm. First we have to calculate in the entropy of target, then calculate the gain of each feature, choosing the highest gain feature value. From that highest gain feature we have to split the feature. Again we are getting some subsets of records. To each and every subset again we have to apply the gain information gain formula. We have to repeat that entire process until all the records are comes into which one decision tree. This is about the decision tree algorithm. Guys, hope you're all understood. Okay, so thank you.